Here we go. 2015, question 2. Let's do it. Now, the question states, to increase business, an owner of a restaurant is running a promotion in which the customer bill could be randomly selected to receive a discount. So we imagine a guy sitting here at the cash register. He's checking out customers. And so I think in class I talked about Chipotle. There's always a big line of people. And imagine that the cash register has some type of computer program in it, and just randomly, when the customer's bill is printed here, a program in the cash register is going to randomly generate whether or not that customer receives a discount. So that might mean this guy does, and this guy behind him and in front of him don't. Now, the program was written to generate a discount with a probability of 0.2. So it's 20% of the people that he services on a daily basis are supposed to get a discount. However, the owner has concerns that the program has a mistake, and this is resulting in not generating long-term proportions of 0.02. Now, we could do a statistical test, but they've decided to do a confidence interval, and they did a lot of it for us. So let's keep reading. The owner selects a random sample of bills, so we don't really know what N is. He selects it and found that only 15% of them received a discount. So that's his sample proportion. And so we don't really know, but we could kind of guess that if he talked to 100, let's say he did, hopefully he asked enough people, and that 15 of them did out of a total of 100. And that helps us kind of imagine what happened here. And so immediately he's like, aha, that's not that. But that's not necessarily proof that this isn't working. In fact, there's a likelihood of that outcome happening. So what we're looking for is whether or not we have statistical evidence, which would mean an outcome that's so rare that it does call into question the validity of the program. So it states he did this study and he got a confidence interval of 15% plus or minus 6%. So I'm going to go ahead and just generate this interval by using a simple calculator. Of course, the simple calculator doesn't want to work, so I'm just going to not use it. 15 plus 6% would be 21%. And 15 minus 6% would be 9%. So that's our interval. Does this confidence interval provide statistical evidence that the program is not working? Well, the problem is, notice 0.2 does fit in there, and that's ultimately, based on his study, that's what we're looking for. So we need to restate the question here. The question says, consider this confidence and answer the question, does a confidence interval provide convincing statistical evidence that it is not working? And the answer to that has to be no. The confidence interval from 0.9 to 0.21 does not, I got to commit here, and then I'm just restating the sentence, does not provide convincing statistical evidence that the program is not working as intended. The program was designed to work 20% of the time, and 20 falls in the interval, so that's that, at least based on the information he collected. Now they're saying, does the confidence interval provide convincing evidence that the program generates a discount of 2%? So what they're trying to kind of trick you, because a confidence interval is not proof of, again, we accept H sub O. So it appears as if The accepted truth is that the proportion of the population, if you ran many trials, is supposed to be this. That's the accepted truth. And you have reason to believe it's something less than that. But you always have to start with the accepted truth. So ultimately, when we do a confidence interval, we don't usually write these out, but it's still happening in the background. We are saying this is the accepted truth, and all our sample did is tell us whether or not, cast a net, and let's say this was a 95% confidence interval, we're 95% confident that the true proportion falls somewhere in this range. We're never doing this to figure out if it's exactly this. We're just doing it to figure out if it falls within this range. So we're going to have to once again say no. If they ask me whether or not the confidence interval provided statistical evidence that the discount was 0.2, I have to say no. The confidence, and then I'm just restating the question, confidence interval of 0.9 to 0.21 would be plausible values of the probability of 0.2. And so notice, once again, they kind of are trying to trick you about what a confidence interval is. And again, a confidence interval is a range of numbers where the truth could lie. There's no way from a confidence interval to gather proof that the outcome is exactly 0.2. So the confidence interval would be the plausible values of the probability 0.2. Therefore, a confidence interval wouldn't provide convincing statistical evidence that the discount is 0.2. Thank you for joining us for question 2015, question 2, part A.